Today we are beginning concept 61. We're jumping around simply because this is a big topic in your SAT. Okay, probability statistics. Now today we're going to get into very basic probability. Tomorrow we're going to start looking at the more advanced stuff. Okay, we're going to look at the probability of more than one event happening at the same time. Then we're going to go into permutations and combinations. Then we're going to look at basic statistics, like mean, median, mode, all that kind of stuff, variance, just standard deviation. Okay, all stuff that is fair game on your SAT. Now, what we're going to look at today are single events. Single events. Okay, a single event means simply that. One event occurs. So rolling the dice one time, or flipping a coin one time. The minute I start flipping two coins, or I flip a coin and then another coin, or simultaneously three coins, those are no longer single events. And that's what we're going to look at tomorrow. We're going to look at compound probability and see what happens when we have two events going on at the same time. So, before we start, we need to define three terms that we're going to continue to use. And the hardest part to distinguish is between outcome and event. And a lot of people get them very confused. Now, easiest example here. First of all, the definition of an outcome is the result of a single trial of an experiment. A single trial. An event is simply one or more of those outcomes. One or more of those outcomes. And then probability, you've all heard, is the measure of how likely an event is. Okay, how likely an event is. So, a simple way to think about this, and we'll do it with one of our examples, but what if I had, let's say, I had a tic-tac-toe board. Okay, or a 3x3 matrix. Now, if I were to shade 1, 2, 3 in black, 1, 2, 3 in red, and 3 in green. If I shaded them 3 red, 3 black, 3 green, the probability of getting one of my, for example, green ones here, from what you know already, what would the probability of getting a green, assuming they're all the same size, obviously? Third.
3 out of 9.
3 out of 9. Very good. 3 out of 9. And which is reduced to 1/3, absolutely. I'm glad you said 3 out of 9 for now. So we can all see there's 3 green boxes out of a total of 9, right? 3 out of 9 there. But what is the probability of getting either a red or a green? A red or a green? 6 out of 9, right? So the outcomes of these are green outcome is 1 out of 3. Red outcome is 1 out of 3. The black outcome is 1 out of 3. But the event has to do with the actual scenario. For example, what is the chance of getting a red or a green? That's an event. Because we're looking at one or more of the outcomes. We're not just looking at one of the outcomes. So if you're just looking at each individual outcome, like what is the probability of getting a green, that's where outcome comes in. But when I say what is the probability of getting a green or a red, that's an event occurring. Because there's one or more outcomes in that experiment. Okay, and then probability itself is our definition. So if you're looking at probability of an event, the amount of ways the event Y can occur over the total number of possible outcomes, which is pretty common sense by now. And a lot of you guys have seen this, you know, whether it's in 6th grade, 7th grade, as early as 4th grade, when you looked at spinners, and you took a spinner and you would spin it, and you had a 1/4 chance of landing in the spinner. Okay, this is basic stuff that you've seen. What we're going to do is look at some more complicated stuff than that. We got this down so far? Okay, look at the first one yourself. The first one should be very, very simple. Write it down, do it on your own. Write it down, just simply do it on your own. You should be done after you write it down within like 20 seconds. Get the connection for pencils over there, Jay?
Oh, I had them.
I still have mine, actually. I'd like it back.
Remember I borrowed the Tech Hunter Road one yesterday? No. I put it back. I thought we traded one. I put one back. I give you that one, and then I put another one back when you got to school.
2 years. I thought you had one to learn, it's fine. All right, so somebody raise their hand, explain to us what the answer is and how you did it. Nobody know or is nobody here? Oh, my question?
Yeah.
I just said somebody raise their hand and tell me what the answer is and explain. Come on. It's 1/4, why?
There are 4 sections.
Yeah, again, guys, there's 4 sections here. Draw yourself a circle, split it in 4. One of them is considered to be red. One of them is green. One is blue.
One is black yellow.
And one is, if we can get yellow, there it is.
Black.
One is
That look like green.
yellow.
That's yellow.
Okay, so we've got yellow, green, blue, and red.
Are you serious?
Oh, get over it. There's 1/4. 1/4. Again, Trayvon is right. What he said was there's 4 spots. They are equally sectored, so each spot has the same amount of area. Thus, the probability of getting any of them is 1/4. So how would I write that? The probability of red equals 1/4. That's how I make my statement. And so forth and so on. Probability of green is 1/4. Yellow is 1/4. Blue is 1/4. You don't need to write the whole word every time. You can abbreviate, except when you have like a sector that was blue and one that was black. You can't write P of B, right? You got to write the word blue and then write the word black, because BL isn't even good enough. So make sure you specify what you're doing. Here, you have 4 different letters to start with, so just use those 4 letters in your probability statements. Okay, list 4 times, the other 3 also. Now, let's quickly go on to the next example. Are we clear with this one? Because this is your most basic probability. This would never be a problem in the SAT. Because this is like, I mean, somebody using like 5th grade math that knows enough about chance could do this, right? Wouldn't you agree? If you did that enough, if you had a little game, you could see, oh, it's 1 out of 4. It's 4 spots. It's 1 spot. Okay? So it's not going to be an SAT problem. It's more of just an introduction. Let's look at a second one now. Okay. We've got a single 6-sided die. A single 6-sided die. It's rolled. What is the probability of each outcome? How many outcomes are there?
6.
So what's your answer?
4.
1/6. Again, how many probabilities are there? There are 6 opportunities. Each of them are spaced equally on the dice. Each of them has the exact same amount of surface area. Okay, each of those squares on the cube has the same amount of surface area. What is the probability of rolling an even number?
1/2.
Why 1/2?
Because you have 3 odd numbers, 3 even.
Yes, very good. So we start. The probability of any of those events, let's say the number 1, that's just 1/6. The same goes for 2, 3, 4, 5, and 6. Now, the probability of 2 or 4 or 6 is what I'm saying next, because those are your evens. You don't have to write those out. You could simply write the probability of an even, like that. Okay? And as Derek noticed, there are 3 even spots out of a total of 6. Thus, the probability of an even is 3 out of 6. Okay? Reduced is 1/2. So you can write it either way. So you don't have to write it this way, but I want you to see what it actually means. So let's make some sort of a conjecture before we move on to the next question. And that conjecture needs to be related to my OR statement. What does the statement OR actually mean now with probability? Who can relate or translate the word OR into something that we know in math? What does it mean? Plus. Very good. Plus. Why plus?
Because when you're saying or, it's like it's both of them.
Yes, the combination of those 2 probabilities. So, the probability of a 2, everybody, is what? Probability of 4 and the probability of 6. When you add those, that's where the 3, 6 comes from. So, what you should be writing down is this. OR indicates plus. Because tomorrow we're going to see something else. Okay, this is our little trick here, our memory tool. When you see OR, think about plus. When you see OR, think about plus. And you're not always going to see or, you're going to see something like this, probability of even. But you need to think about that as being an or statement. 2 or 4 or 6. If I had said prime numbers, what are prime numbers?
1, 3, 5, 7.
Okay, 1 is not considered prime actually. I know it's weird. 1 is the only example that's not considered prime, out of your exceptions, but 2, 3, and 5 would all be prime. So if you said the probability of a prime, it's still 1 out of 6, 1 out of 6, 1 out of 6, summing up to be 3 out of 6.
Why is 1 not a prime?
Okay? For now, just accept it. Mr. Carter, why is 1 not prime, honestly? Because 1 is our identity law of multiplication. So there's no possible way of it having other factors, really, because it is the multiplicative identity. So it's excluded from the idea of being prime versus composite. It's neither. Just, yeah.
Rise of fans.
The idea of composite is that you have more factors, but 1 cannot have more factors because it is the multiplicative identity. Its only factors are 1 and 1 that are integer values, obviously. You can multiply 1/2 times 2, but those are not integers.
Isn't a prime a number where you can't multiply with more numbers together?
Correct, besides itself and 1.
Yeah.
So 3 can only be divided by 1 and 3. But 6 is not prime because it can be divided by 3 and 2. Composite is 6. If you're not prime, you are composite. Are we clear on that, by the way? If you're not prime, you're composite. So your prime numbers are 2, 3, 5, 7, 11, 13, 17, 19. All those numbers can only be divided by 1 in itself. But any other number, like 12, which can be divided by 6, 2, 3, 4, 1, and 12, is composite. If you're not prime, you are composite. 1 is the exception. Okay? You're never going to see a problem where they're going to use 1 in the probability because of the fact that a lot of students are confused whether it's prime or composite. So the problems they give you will avoid considering 1 to be prime or composite. It won't have that. It won't have that decision being needed to be made on the SAT. Take a look at this one now. We've got a jar of marbles. The jar of marbles contains 6 red, 5 green, 8 blue, and 3 yellow. You gotta figure that part out. You can do that. Use the sum property. If a single marble is chosen at random, what is the probability of each of those marbles? Total is 22. 6 and 5 is 11. 11 and 8 is 19. 19 and 3 is 22. How many red marbles do I have?
6.
So, very good. Probability of red is simply 6 out of 22.
Sounds like one of those PBS kids.
Very good. When we simplify, we get 3 11ths.
That's right. 5 out of 20.
John Green. Probability 5 out of 22. Easy stuff, right, guys? Probability of blue is,
Oh, Mark's math show. That'd be awesome. It'd be like a little Mark.
which is,
Have a little bit.
and finally yellow, which I'm going to do in black. Good. Okay? Again, we've got 4 different probabilities here. Are they equally spaced this time? Or equally distributed? No, they're not. Very good, they're not. How come they're not equally distributed? Explain. Why? Why are they not?
Because they don't have the same number over. They don't have the same number at the top and the bottom.
Okay, that's mathematically, logically, why are they not? Good, their amounts are different. Their amounts are all different. So they're not going to be equally distributed. So immediately, guys, whenever you have unequal amounts, you know that your probabilities will automatically be unequal. Okay, again, 4 different probabilities because we have 4 different amounts of marbles. Probability of getting a red or a blue. Red or a blue.
Yeah, that's 14 over 22.
Very good. Again, red is 6 out of 22. This is 8 out of 22, which is 14 out of 22, which is 7 over 11, coming from the 3 out of 11 plus 4 out of 11. So you can simply add your fractions together. Now, if you're going to add them together, you need the same denominator. So if I want the probability of blue or green, what is that one going to be?
It's 13.
Good, 13 out of 22. Because for the blue portion, I have to use my non-simplified fraction so that I can add it to the green portion. If I did probability of blue or green, it's going to be 8 plus 5 or 13. Okay, we're clear on that?
Yeah.
All right, good. Last example before we get to a little more difficult stuff. Choose a number at random from 1 to 5.
Negative
What is the probability of each outcome? What is the probability that a number is even? What is the probability that a number is odd? Quickly, each outcome is probability
1 out of 5.
1 out of 5.
Probability of
Probability of
a
a 1, a probability of a 2, a probability of 3, a probability of 4, a probability of 5 is all 1/5.
probability of an even number would be 2 out of 5.
Even is,
2 out of 5.
odd is,
3 out of 5.
what do they sum up to?
5 out of 5.
Which is all the probabilities, always 1. Okay, so note that please. Probability of an
We
odd
just made them more complicated.
is 3/5. Probability of even
You always say that about it.
is 2/5. Together, they make up 5/5. The probability of any event must be 1. Must be 1. Think about this. If I said, what is the probability of getting a 1, 2, 3, 4, or 5? What's the probability? 1. Again. Really? Uh-oh, that's a problem. Hold on one second.
What happened? Hey, dude. No, the computer's just broke. You know what I just heard?
It should be there in about a minute. If it's not, this is it. But you can't use double-sided feature. So it'd have to be single-sided, stapled, 22 copies. It should be done though. You know what was the problem? I wasn't connected to the network drive, so it doesn't automatically bounce the printer back. So it should be there. But if not, 22 copies. You want a little code?
It's not for grade, it's for extra.
Thank you, Mr. Blanc.
But he recommends that you
He recommends that we should go. Recommends that we should go.
So,
22, single-sided, stapled, code is there. It should be there though, okay? Thank you, Lee. Sorry about that.
Mr. Haskell,
John.
real quick, why, before you try that out, what I just said about the PBS kid show thing, there's actually a YouTube, there's actually this video maker that you can do with Mark Houston.
Really?
You could do that for your class, like you could make lessons and you could draw a little version of yourself. I could do it for you, and you would actually do it.
You'll be the artist?
Yeah.
Put on my desk. Did you put on my
It's
desk?
actually really awesome. You could do it. I think you could do that. You would actually.
Here. All right, so back to what you're saying. If you were ever given a scenario and they say, what is the probability of 1, 2, 3, 4, or 5? Those are all your chances. So if they give you the probability of all of them, if the answer is just 1, it'd be like saying this. I've got a coin. Okay? Everybody got a coin in their pocket? All right. So if you flip the coin, what's the probability of getting heads?
I get to know.
Probability of getting tails. So if I say what's the probability of getting heads or tails? 2 out of 2, which is just 1. Again, the probability of getting any of the possible events summed up is always going to be 1. Always. So what does that tell me about my probability? Okay.
It won't go more than 1.
It won't go more than 1. Very good, Claudia. So probability,
Legs too short.
listen, the domain of a probability function is really from 0 to 1. Because there is a chance of getting 0. If I had a 6-sided die and I said, John, stop doing that, and then I said, John, what's the probability of you rolling an 8? What's the probability of you rolling an 8, John? Really? On a 6-sided die?
6-sided die.
There's an 8 on there? Derek, relax.
It's 0.
It's 0. There's no 8 on there.
I was pretty sure it was an 8 on the
Okay.
die.
It'd be like me saying, here, guys, what's the probability of me picking 7?
There's no 7.
It's 1 to 5. There's no 7. So what you want to write down is that the domain for a probability function is really going to be from 0 to 1, inclusive. That's what our domain is, really. And I know you're never going to see domain here, because you're not going to study functions this year for probability, but it's good to think about. It's really good to think about. You can't have any probability more than 1. You can't have anything less than 0. Okay? This is where we tie Algebra 2 into probability. This is no longer just 6th grade probability. In a minute, we're going to look at geometric probability, which is a major topic on your SAT exam. It occurs a lot. And we did it last year, so it should be a little bit of a, recollection.
What's geometric probability?
Having shapes like a dartboard. What's the chance of landing in one of those regions?
Oh, yeah.
We did it last year. It's pretty basic stuff, right? All right, so just do this. Geometric probability. Here we go. We'll start with a very basic shape.
Q. What kind of draw a Q? Is that a Q?
No, that's a rectangle.
Probability of landing in the green region out of the whole square.
1/2.
1/2. Okay, or whole rectangle, sorry.
Oh, no.
1/2, right? Okay.
Shut up, Jason.
Probability of landing in the red region.
1/3.
1/4. Very
Oh, yeah, it is
good.
1/4.
Because Juliet is noticing. Watch what happens, guys. If you connect these, we're really splitting it into 4, assuming it's a square, obviously. Sorry, we'll assume it's a square. Okay, let's put my markings in. 1 right angle, 2 congruent sides, automatically a square. So, in this case, Juliet thought, well, the red region is really half of this half. That's where the 1/4 comes from. Again, this is half of this half. Now, if you had this region here as a black region, then we shaded this region as a red region, what is this now the same thing as?
I'll be consistent.
Okay, 2/4, but I'm asking what kind of a shape is this back to that we did in the beginning?
A rectangle.
Oh,
What was our first
1/2.
example we did, guys?
1/2.
What was it? A spinner. And how many spots? 4 spots. This is actually the same thing, even though it's not a circle. Because now, assuming again this is a square, these are 4 equal regions of area. When you take a square, and I'll draw one better to scale here. When you take a square and draw diagonals, you have 4 equal regions. So, a spinner does not have to be circular. A spinner can be square. It does not have to be circular. Okay, so don't assume just because you hear that it's a spinner, it's circular. It could be a square one. Okay. Yes. Thank you. Now, that's a very basic one, right? Let's look at another one. We've got a rectangle to start. We'll say the dimensions are 10 by 8. We'll say centimeters for each. We need units. Okay. We've then got a triangle in this region. We're going to shade our triangle. And we're going to say, what is the probability of landing in the shaded region? Okay? You can't just do it by inspection right now, can you? I'll tell you right now, it's not going to be 1/4.
Find the area.
Is it by area?
Rectangle and then find the area.
It is 1/4.
Well done.
Just there's no.
Let's go through and look at this one here. If, make it 1/4. Let's figure it out. If we want to do this, Juliet just stated for us, whenever we do these problems, if you want to know the probability of landing in a shaded region, you take the shaded over the total. Shaded over the total. Okay, so this is equal to the area of the shaded over the area of the total. If you want to write out the words, you can write them out. Anytime you do geometric probability, the same rule applies. No matter what, is it still 1/4? Thank you. Still was 1/4, so Eric, nice work. Okay, but again, I don't want you to assume it. I know it is because it's a rectangle, but had it been like a parallelogram, it might be different. Okay, and I also happen to pick the midpoint there. Okay, if I didn't pick the midpoint, it wouldn't work. So, what is the area of the shaded region? What kind of a shape is that? Triangle. The base length is 10. The height of the triangle is 4. Okay, the base is 10, the height is 4. Turn your head, okay? So the probability is going to be 1/2 times the base times the height in either order, all over the whole area. Again, the area of the triangle over the total entire area here, it's going to be half of 40, which is going to be 20 over 80, or 1/4. I apologize, it was 1/4. Again, the reason this is 1/4 is one reason alone. This triangle, its vertex is at the center of the rectangle, or the centroid is what you would call it mathematically. But it's at the center of the rectangle. If this had not been there, if I had drawn it like this, and this had been a height of 3, clearly it would have been different, right? We have used 3 instead of 4, so the area would have been different. Let's look at a more complicated one, because again, this was very basic. So we have a triangle over a rectangle.
Mr. House.
Okay, yeah, John.
Okay, let's say it was like a rectangle, right? And like, I mean, right there, like when you did the triangle and you were figuring out the map, obviously it was half. Like, let's say it was less, and like you weren't sure exactly sure. How do you? It's got to be given.
Got to be given. Or we'll say this, John. They'll call this x, and they'll say this is 1/2 x. We'll do that problem now, okay? Rectangle with a side length of y, a base length of x, a triangle from there that is isosceles with a height of 1/3 x. Find the probability of landing in the triangle. I didn't shade it, but I'm telling you, triangle. Find the probability of landing in the triangle. Go.
So we're doing this on our own.
Sure, sure.
Wait, wait.
What?
Y'all need to put dates.
Because you can do it quickly. This one you're try. So the probability of landing in the triangle, please. If you get it, just hold on for a sec. Okay, I'll come look, that's fine. You don't yell out the answer, please. Good. Now, Jason, cancel this. Circle that. Get your answer. Hold on. Circle your answer. Good. And I'll tell you now, it's going to be a numerical value. It's going to be a numerical value only. You'll figure out why if you do it. This right here is a perfect SAT problem. Okay? I mean, it really is. Because a lot of people get confused with the X's and Y's. Okay. Top is good, bottom is just like, come on. Yep. That's why I told you to do that. Let's see what you got. Top, see how the triangle down below the You got it? Okay, bottom's good, the top's good so far.
Wouldn't it be a direct line?
Okay, write out the formula you would use to find the area of that triangle in terms of the variance. Now, figure out what you have to do next.
Yeah, substantial, yeah.
Where's the height?
So the answer's 5.
It is a 1, not a 5.
Alright, let's see.
Do 1/3 times 1/6? 1/2 times 1/6? Right? In your app?
And we just got only like 2 years old.
I did 0.5 times 0.2 times 3.3.
0.3. Do 1/3 times 1/6. As a fraction. Alright, so, let's do this.
No, it's 1/6. 1 times 1. 1/6.
That's what I'm doing, right? Area of the triangle over area of the rectangle. But everything is in variables. So let's solve this in variable form. So here, The area of a triangle is 1/2 base times height. What is the base of this triangle? Y. Very good, Jason. Turn your head, please. This is your base here. This is your height. How do I know 1/3 x is my height? I don't see a right angle there.
It's reading from the base to the top.
What kind of a triangle is this, guys? When you draw an altitude from an isosceles, it's always going to be at a right angle. Again, when you draw an altitude here, as your altitude, this is going to be a right angle. Because an isosceles gets split down the middle, there are two right triangles always. Okay? So, I've got 1/2 times the base times the height. That's what you need to write down. Because y is the base and 1/3 x is the height. What's the area of the rectangle? Everybody, what's the area of the rectangle? Yx, very good. Length times width, or xy, either one, right? So yx. So what's on top and the bottom? So they cancel. What am I left with? 1/6. Because I have 1/2 times 1/3, which is 1/6. So the probability of landing in that triangle is 1/6. So, follow-up question. If I wanted to draw a bunch of triangles inside of that rectangle, how many can I draw? 6. Right? Because the probability is 1/6. So isn't there really 6 triangles in there? That's what it really means. Think about that for a second. Again, if the probability is 1/6, it means that the triangle has 1/6 of the area. So if I were to put triangles in there, I could fill that rectangle with 6 of those triangles.
The small one is out of order, so they don't get it manually.
Thank you,
So
sir.
that's what we're
Sorry for help. Sorry for thanks. I appreciate it.
Huh?
Thanks, Luis. Okay. It's gonna be okay. All right, next one. Let's do one with a circle now. A lot of people get confused because pi is involved. Don't let it bother you. It's a number, like anything else.
Geometry.
So let's say I've got a square here with a circle inscribed in it. Okay, a circle inscribed inside of a square. That's pretty good for me there. Let's say that the side length is 10 inches. And it says, find the probability of landing in the shaded region. So what's the shade that's shaded? What's the shade that's the total? So we do a circle over a square.
We're just going to look out for a day. So when the radius be
Okay?
5 inches.
Probability of a shaded region is the area of the circle over the area of the square. Juliet?
Is the base also
It's a square.
It's a square.
Never mind.
Okay? Again, the statement we started with was that this is a square and a circle. Square cool?
I know what it is. Wouldn't it be pi 5 squared?
So,
Yeah, no, but the thing would be pi.
we have to start, as Derek just mentioned, by writing down what our radius is. What is our radius, everybody? 5. I didn't ask what the circumference was. That's too clear. I said, what's the radius? So the radius is most definitely pi. Most definitely pi. Now, let's go ahead and plug in. Area of a circle is pi r squared. Area of a square is just side squared. Okay, again, area of a circle. These are given on the test, but you've got to memorize this stuff, guys. You need to know the area of a circle by now. Okay, the area of the square especially. So you got 25 pi over 100, right? What does that reduce to?
1/4 pi.
Or just pi over 4, right? Again, We get 25 pi over 100, which is most definitely 1/4 pi, but we can write that as pi over 4. Now, I've got a question for you. If the probability of landing in the shaded region is pi over 4, what's the probability of not landing in the shaded region? Or the unshaded region? What is it? Close, very close. 100%, or just 1. What is pi over 4? Everybody go, type it in. Pi over 4. Give me the exact decimal. What do you get when you do pi over 4?
3.145.
That's pi. Pi over 4.
Oh, 0.7853.
That's the probability of landing in that circle, right? So not landing in the circle is what's left over, because we know that all the probabilities always add up to 1, just like we said a minute ago. Remember before when I said, and that's why that was important, I said you roll a dice, there are 6 outcomes. The chance of getting 1, 2, 3, 4, 5, or 6 is just 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, or 6 sixths. So the probability of landing in the square anywhere is 1. So the probability of landing in the unshaded region is just 1 minus the probability of landing in the shaded region. So that's what we want to write down as a correlation here. The probability of landing in the unshaded is 1 minus the probability of a shaded. Always, 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 always. Okay? Again, the chance of landing in that unshaded is 1 minus the probability of the shaded region. So in this case, it would just be 1 minus pi over 4. 1 minus pi over 4. Now, I guarantee you, on the SAT, if they asked you the probability of landing in the unshaded region, the answer would be in terms of pi. Because it would cause you to have to figure out pi over 4, and then also know the correlation between shaded and unshaded. Do you see what I'm saying? A lot of students do this. They get this decimal, and then they say, all right, well, maybe I could do 1 minus that and get another decimal. And then they have to try every single choice. But you guys are smart. Leave it as pi over 4, and if you know that the probability of the unshaded is 1 minus the shaded, you just write 1 minus pi over 4. Okay, and that is your answer. And I'm telling you now, a lot of the time on the SAT, they leave answers in terms of pi. In terms of pi. They don't evaluate the decimal. Okay? But again, the whole idea here is to remember that the probability of any event, if you can look at all of them, is always going to be 1. It's always going to be 1, because it's the sum of all your probabilities. Now, let's take the same example on the next page and look at it. Exact same example, now the sine length of x. What is the probability of landing in the shaded region? Calculate, please. The sine length is x in the square. What is the probability of landing in the shaded region?
So it's radius.
The sine length is x. The rest of it is the right steps.
It's gonna be half X, and then. Oh, you just gave one.
One half x that quantity more is just looking into one parentheses around one half x and then square.
You cancel the
Oh, yeah, so the answer is,
Let me show you how I do it.
Get a numeric value on this one.
No. You see, no.
so what else are we about to have? I got you both reasons for
Some of you have picked up on the trick already, or the coincidence, which is not a coincidence at all.
Doesn't want black Kool-Aid, Trayvon.
All right, let's take a look at the board real quick, and a lot of you picked up on this. The area of the circle is pi r squared, but most people made mistakes with their radius. The radius is 1/2 x. Are we clear on that part? You have to square the entire quantity, thus making 1/4 x squared. What happens to your x squareds? What are you left with? 1/4 pi, which is? What was the last answer, guys? Because look, this is a square that's 10 by 10, right? And isn't the radius half? This is a square that's x by x, and the radius is still half. It's the exact same shape. So the probability of 1/4, or sorry, 1/4 pi, or pi over 4, is the exact same answer again. Who would have thought? So, quick conjecture about circles and squares. If you ever have a circle, you want to write this name? If you ever have a circle inscribed in a square, the probability of landing in the circle will always be pi over 4. When you have a circle inscribed in a square, the probability of landing in the circle is always pi over 4. Always. It's never going to change.
So when we get to the SAT, we just circle.
If that's the problem, absolutely. I would not, I know this, I've had it memorized for a long time. I would never do the math. But again, you're not going to pick up on this until you do more practice, right?
Give me the answer. Oh, I'm a this. 4. This is for USAT. And you're gonna choose.
All right. Tonight, your homework is very, very basic, guys. You've got 8 or so problems that are just asking you probabilities of general stuff. And on the second page, 3 problems with geometric probability. The last one here, the last one down here is a bit tricky. I want you to find the probability of it landing in these little spaces. It says the shaded region, but the shading never came out here. The little spaces outside the circle should all be shaded in. See what I'm saying? So the circles are not shaded. Everything else is shaded besides the circles. So please shade that part in so you know.
They gonna love you for my
Yes.
Can you repeat that sentence?
If there's a circle
Inscribed in a square.
inscribed in a square, yeah.
The house, yeah, the extra.
If there's a circle in a square, yeah, that
Now start all over, but that's
inscribed in a square.
That's it.
No, but 6 times. What's the probably going to do?
I feel like 7.
Circle inscribed in the square.
I have more stupid.
I don't think-
For some reason, I was thinking, oh, 8 and I was doing
If there's a circle inscribed in a square.
I'm more dumb than this.
If you replicate something, what happens to the probability? Got it? Not the circle. For part 3 on the second page, shade in whatever is not the circle.